Hello everyone, welcome to the channel. In today's video, we will walk you through a step-by-step approach to create high-quality mesh for slant holes. GridPro has a dedicated feature for building automated block structure around various types of hole, mainly hole with opening at both ends, that is two-sided holes, one-sided hole, mushroom type punched hole, partial hole. We will focus on addressing the slanted hole using one-sided hole feature. In general, if we have a straight intersecting hole, we can simply select the input surfaces and get a block structure. This gives us the blocking, which includes assignments for each surface, including support surfaces at the intersection with one-to-one connected block assigned to it. And the block like outermost block, which we can use to connect the rest of the blocks of the domain. I have built the domain block structure by using the single block and added inserts around the hole. Merge the innermost block of the domain with the outermost block of the hole. This is an example of how in GridPro we flexibly build blocks using top-down, bottom-up, or a mixed approach. That is, for hole, we create blocking using bottom-up approach. For the rest of the domain, we simply create a block structure using top-down approach and then merge both these topologies seamlessly. Let's check the grid of this block structure. We notice that at the intersection, we achieve high-quality cells with orthogonal cells on the surface. Now let's try the same approach on slant hole surface. I have selected the surface from top, bottom, and hole surface. Additionally, I want to insert plus type blocks into the blocks, which is why I will select this four-sided plus bidirectional insert pattern in the topology type. This is required in the later stage, which I will explain soon. Add peripheral faces to an empty corner group. This adds the outermost blocks to the outermost corner groups, which makes it easy to merge with the rest of the topology. Click Apply. To merge the blocks of the hole into the rest of the domain, here I am adding inserts to match to the block structure of the outermost blocks of the hole to the innermost blocks of the domain. We have a valid topology, so let's run the grid. After running the grid smoother for 500 sweeps and loading it into the UI, we see the reported skewness difference between straight hole grid and slant hole grid. Highlighted cells in red color shows skewness above 0.75. These are around the intersection. Let's take a slice passing through the hole. You can notice the blocks look squeezed. This is mainly due to the angle of inclination of the hole, which is also the cause for the loss of quality. Basically, in the previous topology, you would notice all the blocks are nearly straight, but in this topology, they are turning while going upwards. We need to create a straight block which ends on the surface of the hole. This is where the plus type of insert will help in simply creating a straight block using an internal wrap. Select the highlighted sheet of corner and create an internal wrap. We have created a straight block which intersects the whole surface. We can remove the blocks around this newly created block by merging them except the block which forms boundary layer. Here, as we have minimal block present, we will go ahead and run the grid on this topology. Increase the density in the new block and run the grid. Notice that there is no skewed block here, and also the skewed cells are pushed towards the boundary of the whole surface, and orthogonality is optimized. Now let's compare the skewness of the grids for the straight hole, slant hole without any modification, and slant hole that we just optimized now. We can see the skewness has reduced by approximately 0.18, and the grid has improved. Thanks for watching. We hope this video helps you understand the concept of meshing slant holes with a modified block structure to achieve better quality grid.